Okay, yeah. So there's this little bit more we want to do when it comes to matrices. And it's all connected to something called the inverse of a matrix. And it will become useful in solving simultaneous equation using matrices. Right? So we're going to take it in little bits, right? So here we are looking at the determinant of a matrix. And this is going to be important to finding the inverse of a matrix. And the inverse of a matrix is important in solving simultaneous equations. Right? And we're going to talk about that another day. So what's the determinant of a matrix really? They give it that name because they simply means, they simply want to say that this calculation you're going to do, this number you're going to come up with, will tell you if this matrix has an inverse or not. And if it doesn't have an inverse, you refer to it as a singular matrix. Right? And if it does have an inverse, well, it's non-singular, right? So the matrix, okay, they give you it here, A, B, C, D, right? So that's this matrix here. What's up? Yeah. 1 second. Yeah. Yeah. So this is the matrix here. And they say the determinant is basically you multiply A by D and you minus B by C. Right? And you get some number. If that number is 0, and then you have what we call a singular matrix. And later on, you will know that this matrix wouldn't have an inverse, right? That's a singular matrix. On the other hand, if it's some other number other than 0, well, you have a non-singular matrix, and the matrix does have an inverse. Right? So you can digest that. Let's move this aside and let's do some examples and see. So let's say we want to check out these matrices. Right? You want to check if these here are singular or not, right? Look at matrix A. So what you see happening there? 3 by 4 is 12, minus 2 by 1, which is 2, you're 10. So matrix A is non-singular. It does have a non-zero determinant, right? Let's take matrix B. Okay. So matrix B. So -3 by -2 gives you +6. 5 by 1 gives you 5. You subtract, you get 1. Therefore, matrix B is also non-singular, right? What would you say of matrix C now? Determinant of C is equals to, let's write it out, 4 multiplied by 3 minus -2 multiplied by -6. What will you get? Not 0? So C then,
Yes, sir.
C, matrix C is a singular matrix, right? Another concept you want to learn is this, what we call the adjoint matrix. And let me put that up here. Because these two now, the one about the determinant and then the one about the adjoint, we will combine them and find the inverse of a matrix. So what's the adjoint of a matrix? Right, notice what it is. You swap around A and D, notice. You swap around A and D and you change the sign on B and C. Notice that? Follow that so far?
Yes, sir.
Let's do an example. Right? So you have a matrix 7, 3, 1, 5, and they ask you, what's the adjoint of A? Right? Or A adjoint. You simply swap around 7 and 5. Notice you get 5 and 7. And you change the sign of the 3 and the 1. And that's it. Simple as that. Swap around A and D. And you change the sign on B and C. Is that hard? Let's take 1 minute. Look at this one. You have this matrix here, and you want the adjoint matrix. So you swap around the 3 and the 2. Notice you got 2 there and 3 there now. Let's swap those around. And you change the sign on the -1 and the -7, and you get 1 and 7. And that's it. That's it. That's simple enough. And then finally, what I told you all of this is related to is what we refer to as inverse of a matrix. Inverse of a matrix. If you have a given 2 by 2 matrix, and of course, the guy inverse of 3 by 3 matrix and so, right? Any square matrix, they have an inverse for it. But that's beyond me. That's why we're only sticking to those 2 by 2 matrices. So notice how you get the inverse of a matrix. You first of all find the determinant, 1 over the determinant times the adjoint, right? The adjoint matrix of the original matrix, right? So this is the determinant here, 1 over it, and this is the adjoint of E. Simple as that. And that's why I was telling you about the determinant business and then the adjoint of a matrix. Not much to it. So here it is, a little example. Right, there's a little example here. So you're given this matrix. Well, I kind of clip out a piece, right? You give a matrix 2, 3, 1, 5, and they want you to find the inverse of that matrix, right? So notice first, you calculate the determinant, which is AD minus BC. So 2 by 5 minus 3, 2 by 5 is 10, minus 3 is 7. So your determinant is 7. Next, you have to figure out the adjoint of A or A adjoint. So you swap around the 2 and the 5, notice. 2 and the 5, you swap them around, so you get 5 and 2 there. And you change the sign of the 3 and the 1, so you get minus 3 minus 1. And then you put 1 over your determinant, 1 over your determinant times the adjoint matrix. And then remember, we did scalar multiplication where you multiply everything in front by everything inside here. And you'll have some horrible looking fraction. And that's your inverse. As a little exercise, I want you to take this matrix here. Let me go here. Oh my, what was that? Take the original matrix. Take the original matrix and multiply it by the inverse and see what happens. Right? Try that for yourself. What I would advise you to do, right? Don't take this one and multiply by this one. Remember, this one is really this here, right? So this is what you should do. Take 1 over 7, 5 minus 3 minus 1, 3, times 2, 3, 1, 5. Multiply these two first. Multiply these two. And when you finish, multiply by this. And see what happens. Right? See what happens. I'm not going to do it for you. I want you to practice some. See what happens when you multiply a matrix by its inverse. See what happens. Maybe I can just throw up a second example. So let me move this one inside. So let's say you have a matrix P. Right? And you want to find the inverse of that. So you can do it at one go, right? You can do it at one go. You don't have to do it in those steps you saw just, right? So B inverse, those are two letters that you see recording. B inverse is equals to 1 over the determinant times the adjoint of B, right? Or B adjoint, however you want to be. So you can do all the calculation at one time. 1 over AD minus BC, you do it right here. And then you just swap around minus 4 and 2 and change the sign on 5 and 1. You do all right here. And you simplify and you get this, right? And you can multiply that out, right? You can now multiply that out to give you what? You get a horrible looking fraction. Yeah. Very often you end up with some ugly fraction. Again, for your own, you want to see a little miracle. Take this one and multiply. Don't multiply by this, it's hard. You're going to get a lot of fractions. Multiply it by this here. Put this here. Minus 4, 5, 1, minus 2. Multiply these here, right? And see what happens. I think you're supposed to always get 1, 0, 0, 1. Always. See if that happens. But so I think we did up there for one day. I'm going to show you the use of it a little later. I have to introduce some equations and so just before you go in. I'll show you what I plan to do because I'll stop sharing for a while.